everyone. My name is Dima. I'm from Data team, Test and Deployment Automation. And this is a quest for an alerting perimeter. What this talk will be about. It's not a very techy talk. It will be mostly about general do's and do nots when you set up your alerting perimeter. It's like very one-on-one stuff, so to put it. But I think everybody will enjoy a good refresher. So first, let me ask you a question. What is a stable system? Is it a system that never breaks? Is it a system that recovers easily? Is it a system that's super easy to fix? What does this question have to do with the topic I just mentioned? Let's find out together. And first, let's start with some terminology. I'm going to need a couple of things. First, SLA, Service Level Agreement. It's a set of commitments to support chosen level of availability. And paired definition is SLO, which is Service Level Objective. SLAs are built on top of SLOs. Alerts is it's any notification that something is wrong with your system. And finally, alerting perimeter is a suite of said alerts designed to, well, alert you about the problems within your system. It's a very useful tool to not break your SLOs and SLAs. Even from definition, you can see that these two things, even though they are linked together, they are not the same. SLAs and SLOs are for users of your system. They should not be broken. You should make sure of that. And they usually operate on a large time scale, weeks, months, years. A good example of that would be Slack's SLAs. They provide availability of 99.99% uptime, which means they can afford themselves to have downtime for about 1 hour per year. And if they do break it, they are bound to some form of repercussion. I believe they pay back or give you bonuses if you have a business account there. So something for clients. Alerts, on the other hand, are for developers, for maintainers of the system. They are a way to make sure that your system is healthy. It's a form of a pulse. They can fire from time to time. There is no system that is perfect, and they usually operate on a very granular time scale, like seconds, minutes, maybe hours. So important moment here is that you distinguish between those two, because in our team, we used to use SLA. We've built our alert on top of SLA, which backfired a little bit, because SLA is a good thing. Like, we should provide our users to some guarantees. Like, if people want to know that CD uptime will be like 90%. The problem with that was that if we do break an SLA, we start firing with alerts for quite a while. It may take up to a week for alerts to resolve. This was not acceptable. We still have SLOs, we're just not using them as alerts anymore. So let's discuss next what makes a good alert. A good alert is actionable. You should be able to resolve it. If alert does not tell you what to do, it's not very useful one. Because you will panic, you don't know what to do, what's happening. It puts unneeded stress to your interrupt. Second, good alert rate, it should be stable. Connected to the previous thing, in the sense that you don't want your alerts to overwhelm you. They should fire when you need to do something, and they should not fire randomly, because otherwise you just stop paying attention and you may miss something really crucial. Finally, alerts should be like a canary in the coal mine. It should fire prior other people noticing. So, for example, if your clients come to your channel and complain that something is broken, you should probably have an alert that fires 30 minutes before that. A couple of examples. If you have pretty much any long-running process, you may want to measure its CPU, RAM, and disk usage, depending on the service, but it's very standard stuff. And luckily, we already provide that within Criteo in form of, I believe, in Mesos. It's enabled by default. At least there are dashboards that can measure this. For web services, you would usually measure endpoints performance in the form of error rate, RPS, latency. You can measure both large scale and the small scale. Like, for example, for a particular endpoint that is crucial to your system, you can add additional alert. And the final example for schedulers, you should track probably the consecutive failures or just success in the last n hours, for example, making sure that your data is flowing. Now that we have a couple of examples, let's try and map it to our alerts. Well, we do have an API. So we've decided to add RPS and error rate to make sure that API is alive and healthy. We also have a cron that deploys a canary application every 30 minutes, and we track this, that we have 30 minutes success rate every 30 minutes. And finally, we have several custom domain-based alerts, which are for continuous delivery, continuous deployment system only. For example, we measure amount of workers running. Worker is basically an image container. And we measure amount of containers within those workers. All of these are designed to make sure that our system is healthy and it sustains the loads that our clients in the form of other pipelines put on it. When we once we have a couple of alerts, we can start building alerting perimeter. Let's discuss what good alerting perimeter is. First, I would say that it should be up to date and continuously revisited. Let me give you an example on our own metrics. For example, the metrics that alerts that I mentioned previously was not the first iteration of this alerting perimeter. We also measured latency, but at some point we decided to give it up because, well, partially because it's not needed at the moment. We don't have this problem, and partially because there was some trouble measuring it. Because of troubles, it started firing sporadically, just cluttering our main alerting channel. So we've decided to get rid of it to make sure that our channel is clean. Secondly, workers running, the amount of workers running was not in original set of alerts. It was added once we encountered an incident that a couple of workers disappeared and we started experiencing issues. Our clients were some of them started complaining, and we've decided to add this as a preventive feature to see that we are overwhelmed before our clients know about it. And we also did a couple of adjustments. These are in blue for our other metrics. It's basically, we played around with thresholds to make sure that they are firing at when they should and don't fire when they shouldn't. Second trait of a good alerting perimeter would be integration into development process. What does this mean? This means that when you think about your tickets, the same way that you think about tests, you should think about alerting. But maybe not for a particular ticket, but for example, if you have a migration plan or some design for a long-term thing, you should probably groom inside of it some alerting setup. For example, automated auto updates running alert in CD runtime was designed to make sure that our project to onboard all the pipelines within CD to auto updates, it should go smoothly. Basically, we just check that our updates are running, they're not failing, everything is okay. Once we checked that everything is fine, it was alive for about a month, we've decided to just remove it. It's still on the dashboard, but it doesn't fire anymore. It's just for informational purposes now. Again, we should keep it up to date and we should integrate it. Final, although optional thing, is integration of alerts into release process. We don't have it in Tada, but a couple of our clients, namely RTB and Arbitrage, do use their own alerting dashboards to make sure that their release goes smoothly. It looks quite simple. It's just you deploy to Canary and you run alerting checks. If everything goes fine, you move on. If something is wrong, you backfire to person responsible for release to make a decision whether we should or should not run. There is no perfect way to set up an alerting perimeter, but here is our setup. I think it's works okay for us, so I think I should share it. So we have a couple of Slack channels that namely used for separation purposes. I mentioned this set of alerts earlier. It's not all alerts, to be honest, that we produce. So, but we've decided to extract the main ones and put them into Tada Alerts channel. And this is the channel that our interrupt must react to. If you see an alert there, you should do something about it. And we also extracted less important alerts and named them warnings and put them into a separate channel. Interrupt should still investigate what is happening, but at his own time. Second, and quite important thing, is Grafana board. This is actually the main thing that produces alerts in the alerting channel. And it is merged from 3 different Prometheus data sources, and we use it heavily as a main source of truth. If this board is green, we are mostly confident to say that everything is okay within our system. Finally, we document the stuff because from the Grafana board, it's not always obvious what is happening. So we've created a separate board that just explains, okay, this is firing. What is this? What do I do? What to make sure that our interrupt is not overwhelmed and like has some guidance, some starting point from where he can start to investigate. My talk is actually coming to a close, so let's get back to the question that I asked at the beginning. what is a stable system? Well, if I had to answer that, I would answer it in this way. Stable system is the one that is perceived as stable to the outside observer. So if your clients don't know that all hell is loose and everything is on fire, you're okay. And as the wise person said, stability is in the eye of the beholder. That would be all. Thank you very much.